Today we'll talk about differential die mobile robot. So you can see here, this is the differential die mobile robot. And why this is differential die? Because the velocity of this mobile robot is depend upon the velocity of the difference in the velocity in this two wheel. Okay. So suppose the speed of this two wheel is same. Okay. And both are rotating in same direction. So the overall velocity will be, suppose that is v, and this will be, and this robot will move straight. Okay, but when there will be difference in this the velocity of these wheels, then the robot, the robotic system will start turning. Okay, about a certain instantaneous center. Okay, with a certain turning radius. Okay, so suppose this is not rotating, but this is rotating. Okay, like this. This is rotating like this. In this case, what is happening? The separation between the two will become the turning radius, and this whole system, this robot start rotating about this wheel. Okay. Similarly, when this will rotate, but this will not rotate like this. So what will happen? This will be the turning radius, but the direction will be just opposite. Okay, and this will be center of rotation. Okay, but and again, when this will rotate in clockwise direction, but this will rotate in anti-clockwise direction. So in this case, the whole system rotate about the body center. Okay, so in this case, so let us move to the paper and pen. Okay, so now we will see uh, the kinematic model for this differential diagonal value. Okay, so kinematic modeling of differential drive mobile robot. Okay, so suppose this is the absolute x-axis, and this is absolute y-axis, and this is absolute z-axis, and this x-axis is coming out of the frame. Okay, so this is how we show this. Okay, now suppose this is the differential drive mobile robot. Okay, and this W is the separation between these two wheels. This is first wheel, that is right wheel, and suppose the velocity of this right wheel is VR, and velocity of this left wheel is VL. Okay, and the overall velocity is V. And radius of this wheel is R. Okay, small r. Okay, and this is the body frame. Okay, so body frame x-axis and body frame y-axis of this mobile robot. Okay, now suppose this robot is moving. Okay, and at an instant it is rotating about a point, that is I. Okay, so this I is a instantaneous center of rotation. Okay, ICR. Okay, instantaneous center of rotation means at this point. Okay, this point, at this certain point, this robot is rotating about this axis. Okay, so like this. So suppose this is the rotational velocity, this omega is this rotational velocity, and this is the turning radius, RT is the turning radius of this mobile robot. Okay, now based on this diagram, okay, we will write the equation. So let me clarify here that this mobile robot has 3 degrees of freedom. This robot can move, okay, about x-axis, about y-axis, and this robot can rotate about this absolute z-axis. That is why degree of freedom for this mobile robot is 3. Okay, now based on this diagram, we will write equation. Okay, so omega is turning velocity equal to what? Is equal to v, that is the linear velocity by this turning radius. Okay, and for this right wheel we can write v r equal to rt minus. Okay, so here this will be the turning radius, so that is rt minus w by 2. Okay, so this will be W by 2. Okay, so we can write here W by 2. Again, we can also write for lap wheel PL by RT plus W by 2. Okay, so from this diagram we can write this equation. Now we can also modify this equation. Okay, by doing some mathematical operation, like we will subtract the numerator of these two values. Okay, so what we will get? VR minus VL equal to RT minus W by 2 minus RT minus W by 2. So from here this will be cancelled. We have VR minus VL by minus W, or we can also write VL minus VR equal to W. So again we have this equation. Okay, suppose this is equation 1. Okay. Now case 1. Okay, if suppose velocity of VL is equal to VR. Okay, so if VL equal to VR, so if we will put this value over this equation 1, what will we get? Omega equal to 0. Okay, by W. This omega is W. So theta dot. Okay, let me tell you theta dot so that there will be less confusion. So theta dot equal to 0. Okay, so in this situation, what will happen when velocity of VL equal to VR? In this situation, the turning velocity will be 0. Okay, means this robot will not turn. This will move straight. Okay, in this situation, this robot will move straight like this. Okay, so when velocity of this two wheel will be equal, then this will move straight. There will be turning velocity will be 0. Okay, now case 2. If VL equal to VL but VR equal to 0, means VR is 0 but VL is okay. There is the velocity is VL has some velocity. So what will happen? This robot will rotate about this axis. Okay. So what we see from this, so when we put this over this equation, so what will we get? Theta dot equal to VL by W. Okay, so here the turning radius will be W. Okay, so see here, when this is rotating about this axis, the turning radius is the separation between this two wheel is the turning radius. Okay, like this. And same if VR equal to VR but VL equal to 0, in this case turning velocity will be same but opposite. VR by, okay, so this minus sign, okay, this minus sign indicate the turning radius will be opposite, but turning velocity will be opposite. Okay, turning velocity will be theta dot and this will be opposite, and the turning radius will be W. Okay, again the separation between the wheel. Okay, now case 3. If VL equal to VL but VR equal to minus VL. Okay, means what? VL is there but VRL and VR are same, but this is okay, this is in opposite direction. VL. Okay, so what will happen in that case? In that case we have theta dot equal to 2VL by W equal to VL by W by 2. In this case, R by 2 will be the turning radius. Okay, so see, when this is rotating in this direction, and if this is rotating in this direction, so in this case, the turning radius will be this. Okay, like this. So in this case, in this way, we have understood how the first part of the kinematic model for this differential drive, and in the next part we will establish a mathematical relation between this body frame of the mobile robot with the absolute frame with the absolute frame. Okay, so stay tuned. We will continue in the next video.